para dar el feedback del audio.
Ajá. Este lado, así. ¿Está llegando?
¿Más o menos ahí?
Sí.
Pues vamos a comenzar.
Bien. No quieras.
Good evening, everyone.
Tienes un
Thank you all for joining us
micrófono.
tonight for the season of the Third Market Lovers.
Hello? 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 We'll start again. Good evening, everyone. Thank you all for joining us tonight for another educational session entitled, Is there a need to analyze critical parameters outside the lab, and what's the experience in blood gases? We welcome Ms. Isabel Sastre, who is the product manager from Radiometer, who flew all the way from Spain to be with us tonight. Also, this evening is made possible by Pharmapex, Radiometer, and Lab Knowledge as part of ongoing efforts to provide more frequent opportunities for continuing education. This event is also being live broadcasted by TVP Media Curacao for those who especially cannot be here physically tonight. So our gratitude will be extended to TVP Media Curacao, Pharmapex, Lab Knowledge, Radiometer, also Ms. Isabel Sastre, and of course, our lovely audience. And thank you on behalf of our organizing committee. We wish you all a pleasant and educational night. Before we pass the microphone, we would like to ask you nicely to please silence all your phones. Reserve questions and comments by the end of the presentation. Also, each one of you has been provided a note sheet where you can write your questions, your comments, and also your notes for at the end of the presentation. Lastly, by the end of the presentation, you'll be handed an evaluation form. We kindly ask you to fill in this form and hand it by the front desk where one of our colleagues from Pharmapex will be there. And now, without further delay, please give a round of applause for Isabel Sastre.
I think I have already in my microphone. Good evening, everyone. Thank you very much to invite me to give this talk, and also thank you very much to you to be here to listen to me. Okay, so we are beginning. We say that Radiometer is expert in critical parameters, but we are going to see how we work. So we are going to follow this agenda. I am going to introduce the company briefly. Then I am talking about acid-base balance and oxygen status parameters. I know that those parameters are very complex. Why? Why? It's because normally it's necessary to evaluate several parameters at the same time. It's and depend of the doctor's specialty, they evaluate those parameters just in a different way. But they are very important in departments like ICU, intensive care units, and pneumology, of course, emergency, operating room, several departments more. But nowadays, they want to have their own analyzers. That is happening. But the laboratory was giving and was providing those results of these parameters with a very big quality. It's important, yes. Laboratory provide quality results. But we need to help to everyone, laboratory and other departments where they want to have their own analyzer. Okay. The company Radiometer. Radiometer sounds not any related to medical. It's radio because it was founded in 1935 by two engineers in Denmark to develop measuring devices for radio industry. Is because the name. Then later, there is another very important company in Denmark, manufacturing beer, who asked to Radiometer to develop a pH meter. So it's not was the first pH meter was used to measure acid in beer. But in the middle of Europe, in the year 1952, we had a very big polio epidemic. So a lot of people was very ill with respiratory problems, and Dr. Astrup and Ibsen, Danish doctors, asked to Radiometer to develop a pH meter to measure the pH in blood. Okay, so was when Radiometer began to manufacture pH meters and following parameters related to acid-base status, balance. Radiometer now, since 2004, belong to the Danaher Group, American company. You can see here is Radiometer together Beckman Coulter. What does mean to belong to Danaher Group? That means that we have very strong ethic in business. We need to follow a lot of course to provide our ethic in our work. That is the main thing for Danaher Group. Another thing very important for Danaher is to improve the workflow. So we follow the procedures of Lean. I don't know if you know Lean work. Now it's very well known, but it is most known like Toyota procedures. So we need to study our workflow in a Kaizen and then how we can improve our positions. So Radiometer is a leader company in the world to provide blood gas analyzer. We have a 40% of the market share. So we are very lucky and very happy on this situation. But not only about blood gas analyzers in different models, we provide also samplers, and we have a new instrument of immunoassay to measure cardiac markers like troponin I, troponin T, dimer D, sepsis marks like PCR and procalcitonin. And in the middle we can see a software. We know that informatic systems are very important. The instrument must be connected to the internet or to the informatic systems, and I will go through that later. And also here we can see the word Radiometer Live. It's our work way. That means that Radiometer has a very standard procedures to follow. Yes, everybody in the company knows how it works and how do everything at the same way. So let's begin with the parameters. This is a report, a typical report of one of our blood gas analyzer. We can see a lot of parameters here: pH, PCO2, PO2, calcium, sodium, potassium, chloride, glucose, lactate, bilirubin, oximetry, and many derivate or calculate parameters. Okay. Good. How we can know if there is any acid-base problem? First, we look at the pH. The pH here. The pH determine the acidosis or alkalosis. Then we look PCO2 to see if there is a respiratory problem. Then look at the bicarbonate to see if there is any metabolic problem. And of course, we need to evaluate if there are any compensation and which kind of compensation. Another parameter that is very new those days is the anion gap, an anion gap, to know which is the possible cause of metabolic acidosis. So it's not only important to know is there is a problem in acid base. We need to know what is the cause to have the right decision and put the right treatment to the patient. Okay, let's see a little more. The range of the pH must be very narrow, between 7.35 and 7.45. Okay, it's below 1.35 is acidosis, or higher is alkalosis. Okay, it looks easy, but it's not ever the same. Not so easy. Okay, we have a lot of source of acids. We, in our metabolism, we have production of acids, inorganic acids. If we have like problems, or we have low oxygen, we can produce lactic acid or lactate. Also, we in diabetic situation they have a high production of ketone bodies. Okay, and in a normal way we produce CO2, but we normally breathing we expel the CO2. But okay, the body has a way to regulate the pH, because it's so important maintain the pH in the right way, because the enzymes in the body only works properly if the pH is between 5.35 and 7.45. And the body has chemical buffer system to act very quick. So it's the carbonic acid and biochemistry buffer system. Okay, There is another buffer like phosphate buffer system. Also proteins like albumin and hemoglobin. Not so weak, but is very effective. The respiratory center is acting in minutes. Another system is the renal mechanism that require hours or days to stabilize the pH. But normally those ways to establish, maintain the pH works properly, but in a patient, in a personnel, that system doesn't work. Another very important thing is to maintain the electrolytes equilibrium, very important. It's necessary to have the same cation concentration as an anion concentrations. Okay, that happens in each fluid of the body. Okay, but we measure not every cation, not every anions. We measure some of them, but we don't measure magnesium or proteins charged, positive charged or negative charged proteins or sulfides or phosphates. So we calculate the anion gap. How? We measure sodium, potassium, chloride, bicarbonate. So we can see what is the gap. The gap, normal gap, is between 8 and 16 millimole per liter. Okay, if in another cases is not considered the potassium. So the range in that case is a little different, between 8 and 12 millimole per liter. Okay. What tell this parameter to us? Okay, we measure the anion gap and we see that it's normal. Okay, but it's very important to see which is the chloride concentration, because sometimes happen that we have this normal situation because the bicarbonate is lower, but the chloride is higher. That happens sometimes. But if we have a normal results in the anion gap, they give this parameter give us more information. Information, for example, if it's higher, is indicating that we have a production of pathologic acid. Okay, so we need to do so. Which kind? Or where? When? Lactic acidosis, ketoacidosis, methanol ingestion, ethylene glycol ingestion, renal failure. But another case is when we have a low concentration of albumin. It's important to measure the albumin also. Okay, what about the oxygen status? It was very normal to measure PO2 only. But what happened with the transportation? What happened with the release of the oxygen? We know, we have information about that, or we have information about the tissue oxygenation. with the PO2, only with the PO2. No. When we measure oxygen, PO2, only we are measuring 2% of the total oxygen, because solved in the blood only goes the 2% of the total oxygen in the body. The rest, 98%, is transported by the hemoglobin. So we need also, of course, to measure, to have an idea about the hemoglobin concentration. But, okay, have an idea about saturation, because perhaps we know which is PO2, and also we measure saturation. It's possible to know what is the saturation knowing the PO2? No. In the normal case, yes. But normally it's not possible to derivate saturation from the PO2. Why? Why? It's because the way, okay, the shape of this curve is the relation between the PO2 and saturation is ever the same, the shape. But this curve can be to the left or to the right, okay? What does it mean? For example, in the babies, when the baby's born, it has fetal hemoglobin. In that case, it's very important to know that, because this curve is to the left. Why? Because the fetal hemoglobin has a very strong affinity, the hemoglobin for the oxygen. So this curve is to the left. But another situation, for example, intensive care units, when it's very important the oxygenation, the patient who has lost a lot of blood, the doctors want that release of oxygenation to the tissues can be good. How they can do it? They use to have the patient in a little acidity. So when the pH is a little low, this curve is to the right. So that is mean the affinity of the hemoglobin for oxygen is, we can see in this curve, is if it is to the left, is because it's a strong affinity. If it is to the right, it's not so strong, so can release easily oxygen to the tissues. So that is is because this curve is moved, so it's not possible to know which is the saturation, only knowing which is the PO2. How we know the position of that curve? We can see if we calculate the parameter P50. The P50 say us where is the curve. So it's another parameter to know the oxygen status. Okay. We have seen a little very quickly the parameters, but those parameters are needed for very different doctors, in very different departments, in emergency, in intensive care units, an operating room, a medical office, pneumology, for example. Those departments, you can imagine how quick they need the parameters because the patient is there, is very ill, They send the sample to the laboratory and they are waiting for the result, and in the meantime, what to do? Only waiting. And then they receive the results. So it's because they ask to have an analyzer. So it's because laboratory people must understand that in other departments they need their own analyzer. But we need a little more to know what is happening when a doctor say, okay, we need this test, collection of the sample, the identification, transport, check the sample, analysis, and then result. Okay, that is a very big, or can be very short or very big in a time. Okay, but in the middle there are some risks. Which are the risks? Okay, the 62% of the risks are in the pre-analytical phase, before analyze. Okay, which are? The first one, in all the quality congress where they are talking about samples and what happened? The main problem is the identification. How we need very quick these results. I take the report and see, okay, but then if I lost this paper, what happened? That is the less problem. It's another. But what about the heparin? We need to use heparin. The heparin must be solid. And also it's very important, if I am going to measure electrolytes, that this heparin be electrolyte balanced. Okay? Okay. You can ask at the end why, if you I don't know if you use liquid heparin. I don't know, but it's important to use solid and balanced heparin in order to have good results. Another thing important, the needle of the syringe, just with syringe. Sorry for my English, it's a little. It's important or no? Sometimes we avoid that point. But this collection of this sample is very painful for the patient. It's very painful. So it's important a short vivo. It's important don't puncture at the opposite artery wall. It's important in radial artery, take the blood in an angle of 45. It's important. Another thing important, if the patient has a catheter, it's very easy to take the blood from there. But it's important, very important, before to take the blood, take enough flash solution in order not mix the first solution with the blood. Which amount of flash solution is necessary to take before? Is 2 or 3 times the depth volume of the catheter. Another thing, bubbles. What about the bubbles? It's necessary to expel the bubbles. Very important. Okay, but how we do it? Tapping the syringe, tapping the syringe, but in a safety way, because sometimes splash. So how do that? Using a painted cap is important. Another thing important, if we are going to measure hemoglobin, we need to homogenize well the sample, moving gently, no like that, no shaking, only gently in that way. It's very important. Okay. What about if we need to wait a little between the collection of the blood and the analysis? How much time can I wait? Five. Never more than 30 minutes. How many times? The most important is 5 minutes. 5 minutes. But in the laboratory, never do that before. Okay, that sometimes happens that the blood is collected, and when they have several samples, goes to the laboratory. So, okay, it's not the best. It's not the best. Is if you need to know which is the oxygen status, is 5 minutes. It's 5 minutes if you want to know which is the oxygen status, no more. Mainly, also the blood of the babies. When the babies, the blood of the babies is a little different because they have a lot of red cells. So they consume a lot of oxygen very quick. Also consumes glucose. So it's very important in babies to analyze their blood very quick, because it's impossible in other case to have the right results. Okay, so radiometer supplies not only analyzers of the last technology. For us it's very important to use the last technology, last advance. Okay, it's very important. We have in our instruments. But for us it's very important which is the team, the human team, that they need provide an efficient and effective solution. So we need to know which is the workflow of our customers, to give them a solution, to explain about the phase, the pre-analytical phase, which are the risks, and give them the best solution. But ever simple, safe for the operator, with a broad parameter profile, easy to use, total availability, high quality results, data management. Okay, but also a very important point is the service. Not this because the analyzer needs service, okay, but the customer needs to be in a safety way, to know that in an emergency they have a support. So in our analyzer we have remote support. we have in our instruments the possibility very easily that the service guy in the office look at how is working the analyzer. That is not only wait to the customer call. It's necessary to be more on the service, to give a good service. So we have compact analyzers, small one with battery, and benchtop analyzer. Okay. Not only to measure whole blood, it's necessary sometimes to measure serum, plasma, cephalorachid, or liquid, pleural liquid. Samples not only syringe or capillary. The instrument has also built in the analyzer video tutorials and a very easy software to follow. Now we have this analyze is the benchtop, the unique in the market to have a sampler, automatic sampler. You leave the syringe there and automatically the instrument analyzes that, because it has also a code reader. The instrument knows which is the parameter from which is the patient. And we have different profiles of parameters. You can push a kit and select a profile of parameters, electrolytes only, or the whole parameters, or oximetry, only that. We have results in the screen, in a printer, and we can see if there is any abnormal result, because we have also the normal range at the right of each parameter. Also, we provide an acid-base graphic in order to help to know what is the problem, if there is chronic metabolic acid, or if is it acute, or what is that. That graphic you can get it from the analyzer. Also, to follow the quality in a very good way, to follow the results in Levy-Jennings graphics to know if everything is going good. Also, we have not also graphics, but also statistics reports. We provide samplers. Samplers also because we are thinking about security, user security. We was talking about the short vivo of the needle. Okay, we was talking about when we tap the syringe to have a cap, proper cap, to avoid the splash. We need to avoid the puncture of the nurse when he's collecting the sample. And we have a plastic capillary to avoid the breakage, because it's very difficult to take the sample in a capillary. And it's very important that this capillary can be also plastic, avoid to break it. Okay, so we have analyzers, but we, how I said, we give training to the operators is very important. In everything, not only in the use of the analyzer, it's very important to know well how is the pre-analytical phase. That the process in the right time, in according with the quality rules. Okay, everything with a middleware. What does that mean? It's a software that For example, the instrument can be in a place, in another city, but the laboratory is giving control and helping the use of that analyzer in another city, okay? But in the laboratory can have a computer and see how it's working. How can see that? That way. In the screen, it's possible only with a computer using an IP address can afford this picture to know how are the instruments in a green light traffic lights. Traffic lights in a green, everything is working properly. Yellow means that something is happening, and red is a problem. Okay. You can see in each instrument how was the quality control. You can know how was the calibrations. You can know if there is something that is happening. For example, here we can a yellow light, traffic light. Okay, something is going to happen. The ring solution is almost empty, so I am going to need to change this reagent. So it's not very important, but say me, okay, it's a warning. You need to replace that solution. Okay, but also it's like I was in front of the instrument, in front the screen of the instrument, because you can ask from my computer to ask a calibration, to ask a quality control, or to ask a cleaning or rinse. But we are thinking about our service. Our service is to help to everybody. How? With planifications, with custom installations, training, giving training, meetings to review if we are doing the things that we planning. Very important, technical support 24 hours per day, 7 days per week. Also very important, the remote support is very important. Software upgrades, of course, regulatory support, workflow optimization, and more meetings to follow our work. So we don't sell an instrument, we want to work with you because it's a win-win. You are happy with us and we can follow increasing our products because we see what are your needs. It's very important for us to know what are your needs. Okay, and the last one is to show you that you can see a lot of information in several web pages. One is in English, the first one is in English, it's an American one. Another is Dutch from Netherlands. And another is in Spanish from Spain. So you can see, if I can, okay. What kind of information you can find in that way, web. You can have information about our products, Okay, the instruments, blood gas testing, samplers, transcutaneous monitoring also for the babies. And here you can have the news. You can. Now the page is not working properly. I don't know why. I'm going to check the Dutch one. It's the same. Okay. In any case, you can find there information, knowledge, because we have also a page, web page with a lot of articles, but scientific articles, not about products. Okay, scientific articles. Also, we do webinars, so you can follow the next webinars or to review the old webinars already made. So it's very useful, I think, when you have any time. If you need to check something that perhaps you can, it can help to you, you can use the web page. And also, you can ask us. Okay, thank you very much. Questions? Yes.
I have a question. You mentioned in one of those sheets. I have a question. You mentioned in one of your sheets when you take samples, for example, for blood, that you should tap the syringe so bubbles can escape. Basically, my question is, what will happen if someone doesn't tap the syringe? Does it affect the results in one of the? Sorry. Does it?
If you don't raise.
I'm sorry. If you don't tap the blood, my question is, what will happen if you don't tap so the bubbles can escape? And if it has like effect in the results when analyzing it?
Is that there's the big, because you are measuring gas, PCO2 and PO2. If you don't release the bubbles, you have a big problem, because it's the parameters change. So it's very, very important. So important that we have a case in gynecology in Spain, and in many countries. They used to, in gynecology, see how is the pain of the fetal pain. When they take the gynecology take blood for the scalp of the fetal scalp, and they use that the result of pH to know if it's necessary to make a surgery to take out the baby or not, or he can wait a little more. And that is, one day we receive in our office a letter to explain to the law, what does that mean? It was a warning in the report telling bubbles in the blood. What does it mean? We have that. that means that there is bubble. In the bubble, there isn't any CO2. When the fetal is suffering, is in pain, the CO2 in blood is increasing, is high. So in that baby, the CO2 was very high. But when there is a bubble there, exchange the CO2 from the bubble goes to the blood, goes to the bubble, and the blood lost CO2. What does it mean? If the CO2 low, the pH is high. And in that case, the doctor has a problem because the CO2 in the fetal was very high. But with the bubbles, the analyzer couldn't see that CO2 was high. So it was a wrong decision for the doctor take in account of that report, because was a warning telling him that the CO2 result was bad because in the sample was bubbles. So it's a very big problem because change CO2, change pH.
Are there more questions? Hi, good evening, Isabel. I have a question about the machine. How user-friendly is it, and what about the maintenance?
But the maintenance?
The maintenance of the machine.
Maintenance of machine is easy. Normally, they need to replace the consumables. Which are the consumables? Consumables. Sorry. But so the solutions or the sensor cassette. For example, we have two different instruments. One is cassette basis, is the bench, another bench top. Big one, they have different solutions, calibration, rinse, and cleaning solution. Also waste. Okay, that in the big one. In the small one, we have a sensor cassette, small one, and solution pack. The instrument knows how it's empty. So you need to change. That is all. But perhaps you are thinking about clothes. Coagulos, clothes.
About the maintenance in particularly, because some machines...
For example, 30 days in a month,
okay,
you need to change the sensor cassette. Okay? Sensor cassette. Sensor cassette, if we have two different instruments. One are using sensor cassettes, but you need to change, is ready to work since during 30 days. After 30 days, you need to change the sensor cassette. Okay? And another instrument has solutions. Normally, depend of which solution. For example, some of them is possible to use it during 2 months. Okay? And others, 1 month. But change that solution is only 1 or 2 minutes, no more.
Thank you.
Yes. Okay.
Do we have other questions? No? Can you elaborate a little bit more on the issue of quality control and calibration? You mentioned it, but can you elaborate a little bit more?
Okay. The instrument needs calibration, of course. How often they need calibrations? That because, okay, they make, okay, there are two kinds of calibration. One is 1 point calibration and 2 points calibrations. 2 points calibration is not very often. Is perhaps in one instrument, the calibration of 2 points calibration is, for example, in ABL 90 is PO2, for example, each 24 hours, one, the 2 points calibration. But with each sample makes 1 point calibration, but it takes only seconds, no more. So in another is each 4 hours, each 4 hours in another case, depend of the analyzer. And the quality control is very important to use it. We use it to verify that calibration is good for once. Another use of quality control, we do it each 8 hours, and we follow if there is any contamination or there is any problem. And it's also very important to have a statistic report monthly to report which was the quality, how was working the instrument during month. That is the usage for the quality control.
Okay. Oops. If there is no more questions, I want to thank Isabel for coming from Spain to Curacao to have this inspiring lecture for us today. I want to thank you to come to our lecture. I also want to thank the other ones that follow us on the live streaming. I want to thank you on behalf of Fermentex, Radiometer, and Lab Knowledge. Before we leave, I want to remember you to fill in our evaluation form, and we have also drinks and snacks for you when you leaving this room at your right hand. Thank you for coming, and safe drive to home later on. Thank you.
Thank you.